So before we do matrix multiplication, there's another thing you need to know about a matrix. So this is a matrix. This is a 2 by 2 matrix. Another way of writing a 2 by 2 matrix is A11, A12, A21, A22. So what does this mean? So suppose we take this. We take A12. What does A12 mean? What A12 means is from the matrix A, this is the element from the first row, second column. If we take A22, so 2, 2, that means this is from the second row, second column. And if we have a 3 by 3 matrix, what can we write? We can write A11, A12, A13, A21, A22, A23, A31, A32, A33. So if we take this matrix, A23, what does this mean? This is the element, A23 is the element that can be found on the second row and the third column of the matrix. Second row, third column. So second row, this is the second row and the third column. And so this right here. So this is how you identify unique elements. So if we go back up to one of the matrices that we have used, if we see here, and if I tell you, if I want to talk about this element, what can I say? What I can say is that this is the element that is in the second row and second column. So this is A22. This is in the first row, second column. So this is A12. Okay. So we're going to need this as we move into matrix multiplication. So the first thing that we need to know about matrix multiplication is something called conformity. For two matrices, if we're trying to multiply two matrices, they must conform. So let me give you guys an example. A is, let's just take this matrix, 2, 3, 7, 8. 2, 3, 7, 8. So this is a 2 by 2 matrix. And let's take B. So 6, 3, 2. Now suppose we want to multiply these two matrices. So we want to find A times B. So let's write that down. 2, 3, 7, 8 multiplied by 6, 3, 2, 1. And so this is a 2 by 2 matrix. This is a 2 by 2 matrix. So what I mean by matrix conformity is that the column of the first matrix and the row of the second matrix must be equal. If they are not equal, we cannot multiply. So let me give you guys an example. Once again, let me bring in C. So we have A, B, and we have C, which is 2, 3, 7, 5, 6, 9, 2. So suppose this is what we have, and we want to find AC. So what we get is 2, 3, 7, 8 this multiplied by 2, 3, 5, 6, 9, 2. So let's write down the dimensions. This is a 2 by 2 matrix. What is this? This is a 3 by 2 matrix. So notice straight away that the number of rows, a number of columns in the first matrix and number of rows in the second matrix are not equal, which means we cannot multiply A and C. However, we can multiply A and B since they conform. So let me actually write down the definition. Matrix conformity says that two matrices conform if the number of columns of the pre-multiplying matrix the number of rows of the post-multiplying matrix are equal. Okay, so in case you're confused, so the important terms are conform, pre-multiplying, post-multiplying. Okay, so let's talk about them for a while. So over here we have AB. A is the first matrix. So A is the pre-multiplying matrix. And B is the second matrix. So this is the post-multiplying matrix. So obviously focus on these words, pre and post. That should also tell you guys that when we're multiplying matrix, AB is not equal to BA. So if we have any number, if we have suppose 5 and 6, so we know that 5 times 6 is also equal to 6 times 5. It makes no difference. But for matrices, that's not the case. For matrices, this is important to remember. If you reverse the order, matrix, the value is not the same. So if we come back here, remember we've seen that AC cannot be multiplied because the number of columns in A and the number of rows in C are not the same. But what if we try to multiply CA? C comes first, 2, 3, 5, 6, 9, 2. Multiplied by 2, 3, 7, 8. And this is a 3 by 2 matrix. This is a 2 by 2 matrix. And look what we have here. Number of columns here and the number of rows here are equal, which means that we can multiply C and A, but we could not have multiplied A and C. We're going to learn how to multiply matrices very soon. Don't worry about that. But for now, just appreciate the fact that AC and CA are not the same. So this, what we know about numbers, this is correct. but this does not apply for matrices. Okay, so this is something very important to keep in mind, and it will become relevant soon. Okay, so now finally, let's try and multiply A and B. So A was 2, 3, 7, 8 multiplied by B was 6, 3, 2, 1. And if I write down their dimensions, again, 2, 2, 2, 2. So what we have seen is that because this and this are equal, we can multiply these two matrices. So the next question, so the next question is, what will be the dimension of the resulting matrix? If you multiply A and B are two matrices, the answer will also be a matrix. But what will be the dimension of the resulting matrix? And that is given by this, the other two, 2 and 2, which means when we multiply A and B, we're going to get a 2 by 2 matrix. Let's come up here. We've seen that we can multiply CA, but once we have multiplied C and A, what will be the dimension of the matrix? Well, that is given by this and this. So what we are going to end up with is a 3 by 2 matrix. Okay. So that is how we find out two things. We've learned two things so far. One, which matrices can be multiplied. For example, A and B can be multiplied, B and A can be multiplied, C and A can be multiplied, but A and C cannot be multiplied. So we've learned how to identify which matrices can be multiplied and which cannot. And the second thing we've learned is to find the dimension of the resulting matrix. So when we multiply two matrices, when we multiply two matrices that conform, what will be the dimension of the resulting matrix? We have also learned that. That's green highlighted elements. So basically the row of the pre-multiplying matrix and the column of the post-multiplying matrix. Okay.